In the final question, we have an exponential function which is used to model the value of a car. Now, normally when we have exponential functions, we're looking at something that goes like this and increases in a characteristic shape. You might notice here, however, that because we've got a negative sign here, we're actually going to have the opposite situation, whereby we're going to have the graph actually decreasing at an increasing rate like that. Now, although it is a little bit more complicated to look at in the first instance than your average exponential, it is still an exponential function. So we can use what we know about exponential functions together with our calculator to solve this. So in the first instance, we are asked to find an expression for the car's value when Gabriella first purchased it. So this is our formula. We know that the value is dependent on some variable k, which we don't know at the moment, and t, which is going to be the number of years since the car that was purchased, and we're told that t has to be greater than 0. So the key thing here is to recognise that when she bought it, so when she first bought the car, t, the time, was equal to 0, because there's no years that have passed since she bought it, so time is equal to 0. And effectively then, what we're trying to do is work out v of 0. So, I mean, if you need to, you can plug it into the formula, but you should be able to recognise what this is going to be, because we've got a constant term here, 12,870, and we're going to subtract k multiplied by 1.1 to the power 0. And this whole section here, if we have anything to the power 0, if we have anything to the power 0, as long as it's not actually 0, anything to the power 0, that's going to give us 1. So this whole thing here is going to become 1. So we've got k times 1, which is just k. So you'll notice it says write down and simplify an expression. So in the fact that it says an expression means we're expecting some letters or some variables in it. So if we just simplify this, we'll end up with 12,870 minus k, and we don't know what k is, but that's fine because it says write down an expression. So that is fine for part A. In part B then, we are told that after 2 years, the car's value has decreased to $9,143, which, again, casting your mind back up to here, we're expecting it to depreciate, right? That kind of makes sense with the price of a second-hand car. So how do we use this information to find k? Well, let's have a look at what we know. Let's substitute the information we've got back into the formula up here. So after 2 years then, effectively, we're working out v of 2. So we know that's going to equal 12,870 minus k times 1.1. Now, because k is 2, that's going to be, because t is 2 after 2 years, the exponent here is going to be 2. So we can work that out, and we also actually know what this value is. The value after 2 years is 9,143.2. So we can set that equal to 12,870 minus, and then we can do 1.1 squared, which is going to give us 1.21. So if we multiply this 1.21 by k, we get minus 1.21k. Now, all we're going to do then here is just solve for k. So we've got 1.21k is going to be equal to 12,870 minus 9,143.20, which is going to equal 3,726.8. So therefore, k is going to equal 3,726.8 divided by 1.21, which is going to give you your value of 3,080. So from our initial model for the value, we've actually solved for k, and we've now got this updated version of the exponential function to find the value of this second-hand car. So we're now asked to find when the car value will be $0. So it says here that the model is defined between 0 and some value n because if you think back to our kind of initial sketch at the beginning, at some point here, the car value is going to become 0. And obviously it can't become negative. So the model is only valid up until this point, and we're told that the car will have $0 at this point after n years, and asked to find n. So how on earth are we going to do that? Well, we know that at this point here, the value of the car will be 0. So we can substitute 0 into the value. And then the only other variable that we've got left at this stage is going to be the exponent, which is t, or we can call it n, or whatever we want. So from here, there are kind of two approaches you can do. What I would do, I would just rearrange this equation. So I'm going to have 3080 times 1.1 to the power t is equal to 12,870. And then I would just graph each of these. So my first graph is just going to be y equals 3080 times 1.1. Now on your calculator, you're going to need to put to the power x. And the second one is just going to be y equals 12,870. So they're both positive. So you're going to end up with, here you're going to have some graph exponential function increasing like this. And then we're going to have here, obviously this is a linear function, so we're just going to have this value here. And you need to find the intersection, and you will find that the intersection, where they intersect, there is an x value of 15. So how many years, n, will it be before the car has $0? It will be 15. The other way you could have done this from the last bit is to just plot this function. So we know this is a decreasing function, so you could have just plotted in your calculator straight away 12,870 minus 3,080 times 1.1. Again, it still needs to be to the power x. And then you could have typed in the second graph, which is y equals 0. If you've done it this way, you've got the decreasing function, and then y equals 0 is the x-axis, so you can find it. So either of those ways will give you the answer to the last question in paper 1, which gives you n equals 15 years.